Hey everyone, thanks for joining us for the next session of our RAG Deep Dive series, RAGChat Monitoring and Tracing LLM Calls. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand within 24 to 48 hours right here on the Microsoft Reactor YouTube channel. And with that, I will turn it over to at least one of our presenters for the day. Pamela, thank you so much for joining us.
Hello, everyone. Welcome to our RAG Deep Dive series. And I'm Pamela Fox. I've been here for all of the series. I'm from the Python Cloud Advocacy team. And I'm hoping to get joined by my colleague, Anthony Shaw, also on Python Cloud Advocacy. But we're having a lot of issues with his computer. So he is working on trying to get that computer back in shape right now. But I can talk a lot about this as well. So for those of you who are new to the RAG Deep Dive series, we are diving deep into our most popular RAG solution for Azure. And we're actually almost at the end of the series now. It's an 11-part series, all of the recordings are available on YouTube. If you missed any of the previous ones, you can get the recording, you can get the slides, and you can catch up on what you missed. We do have one more after this next week. And we actually added this by special request of someone in the chat. So we do also watch your chat. So please do be posting questions and comments in the chat, because that's our favorite part of putting on these live streams. So if you want to join us for next week's final session, do register for that session and you'll get an email about it. Now, for those of you who are new to our RAG solution, here's a little screenshot of it, but I'll also go and open up the demo. And this is a demo that all of you can try as well. This demo has the basic functionality enabled. There's actually a lot more functionality available in this repo, a lot more optional features that we've been talking about throughout this series. But this gets you a feel for the basic experience, right? So we can go and we can ask a question. And it goes out and searches an Azure AI search index and gets back matching content, and then sends it to the LLM, gets back an answer to the LLM. We get back an answer with citations. We can click on those citations. We can dive deeper into the PDF where it got that information, right? And see like, oh, okay, yeah, that's what a CEO does. So it makes this information much more accessible. And that's what I really like about these RAG applications, is making information much more accessible, making it easier for people to get answers to their questions. So that is the basic RAGChat. You can check out the full GitHub repo online at aka.ms/RAGChat. You can also check out that demo that I was just showing to get a feel for how it works. Now, this is the basic architecture of it, where we've got the app deployed on either Azure Container Apps or Azure App Service, and we use Azure AI Search to search the documents, and we've got all these document chunks inside there. And then we use Azure OpenAI in order to answer the questions based off those chunks. So the goal of today is to talk about how we can monitor that application. So this is something that's really important when we take this application into production, which many people do. Start with this repo, customize it for their needs, and then start productionizing it. And one aspect of productionizing is adding monitoring, because you want to know, how is your application doing? Like, are there any errors? What's the performance like? What sort of experience are your users having? So it's always really important when you put anything into production that you have good monitoring in place. So today we're going to talk about monitoring with Azure Monitor, with application insights, and how we can use OpenAI telemetry packages in order to send traces to App Insights. We'll also talk about how to set up load tests, because that's a really good way of getting traces and seeing how well your application performs under pressure. And that's something you definitely want to do before you even take it live. And then we can also talk briefly about handling errors from like the OpenAI APIs. And we might have Anthony here. We could try to bring him on now. And let's see how the video is. You're moving. Fingers All right. Anthony, do you want to try sharing your screen? Switching over?
All right.
So Anthony's going to start off with talking about monitoring with
let's try
Azure
that.
Monitor.
I'm going to try stop my camera.
Okay, so we'll turn Anthony's camera off. Now I feel weird being the only. Maybe we should turn my camera off too. All right, we can hear you. Is it sharing your screen?
Okay, cool. Yeah, I'm still having problems.
Okay. All right, so Anthony's working on sharing his screen. So I'll keep going while and we'll see if we can transition over. But basically, so with this repo, we have set it up so that It works well with Azure Monitor and Application Insights. So we've configured everything in the bicep to connect everything. And we've also configured a default dashboard. So you can actually get to that dashboard really easily once you have this repo set up, right? So here I am, I'm in the repo, and I can go ahead and just say AZD monitor. And as you see, it brings up a dashboard here. And what you can see is by default on the dashboard, we just have a few things. You could totally customize this dashboard with whatever you find most helpful to be monitoring, right? But in this case, I added like a reliability column and then a responsiveness column. So the reliability is how I can track failed requests, because that's, obviously what I am the most concerned about is, what sort of 400s and 500s people are getting. And then responsiveness, I'm tracking, latency. So we want to make sure that our latency is within a decent amount of time. So then from there, I can dig further into, into these, right? So I could look at failed requests, right? I might want to see okay, what are these failed requests here? And we can see the top 3 response codes. And we see it's actually all 404s. And that's classic. If you ever run an application, you know that you get all sorts of 404s. Like sometimes it's from, links that used to exist on your website. Sometimes it's because users just type the darndest URLs. And then sometimes it's an actual application issue, right? So in this case, we can look at this and see that all the 404s is this .auth/me URL. And these are actually by design. The way this repo is currently coded is that if you don't have, it checks the .auth/me endpoint to see if there's any sort of authentication enabled on the app. So if there is, then that endpoint will return back with some JSON about the currently authenticated person, and if not, it won't. So that's actually expected for it to get a 404 there, but we could decide well, we're, if we're definitely not going to use authentication, well, we could just take out that call to auth/me, and then we won't get those 404s anymore, right? Now we can also dig into performance. So if we go back here, and this brings us to the performance tab in App Insights. And what you can see here is all those times and durations. So distribution of durations, right? So you can kind of get a feel for, you can look at average, 50th, 95th, 99th, see in the 99th, I see one that took 4 seconds. And that's really slow, but also with an application that uses an LLM, well, that actually could happen, right? Because this duration, it's going to depend on how long the LLM spent thinking about it, how long the search took, right? So we might see durations like this. Now, what we want to keep in mind is this how long it took to get to the first token, or is this how long it took to get to the last token? Because it's always going to take a decent amount of time to get to the last token if it's a streaming response. But if it takes 4 seconds to get to the first token, we might say well, that's too long, right? So we want to see okay, is this on the stream endpoint? It is. All right, well, maybe I consider that to be too slow. So now what we can do is you can actually click on this, so I can click on /chat/stream, because that's what I really care about is, these requests to the chat endpoint. And so I can look specifically into these. And then there's this drill into samples here. So you see down here, drill into samples. So I can click on that. And what you see is all these /chat/streams. And we could look at a particular one, right? We could look at, let's find that really slow one, 4.1 seconds. Okay, so I found the 4.1 seconds. And now I can dig into it here. And what this shows me is what is, basically all the steps that happened in this particular request, everything that was logged into OpenTelemetry. Okay, I think that Anthony might be able to join. Let's try it.
Hello.
Oh, I see you're on your phone. Yay.
I'm on my phone. It's the best device for doing this.
Okay. Wait, does your phone Is your phone also going to present, or are you going to talk over my screen?
I'm going to see. We're going to talk over your screen, I think.
Okay,
So
yeah, that works. Great.
That's okay. Yeah, it's the app I provisioned yesterday. So everybody, so sorry about this. I need a new computer, and I will sort that out after the stream. Yeah, so what Pamela is showing, I guess, when we're looking at tracing with LLMs, or applications that build on LLMs, there's a lot of components really that you want to understand. And this is true really for any application, but if you're looking at the performance of the app, you want to understand like which calls are taking a lot of time. And then if one of those steps fails or takes a long time, then you want to understand why that's happened. And over the last, I think, 12, maybe 18 months, we've been working really hard on contributing to a standard that defines what a trace should look like for an LLM, and what attributes we should capture in a trace, and also contributing to the sort of open spec and the open standards for telemetry and OpenTelemetry. So what Pamela is showing here is an end-to-end trace of one of the requests with streaming enabled, this one. One of the requests end-to-end and showing you like what's actually involved. And in our RAG app, we've got, there's kind of like this sort of the three-step process, I guess, which is the initial call comes in from the user, we authenticate the backend, and then we do an initial LLM query to kind of prep the question. So we sort of have a pre LLM stage, I guess, a pre-RAG step. What do we call it now? Query prep.
I call it the query rewriting step, right? Where we're taking the user's query and the rest of the conversation, right? And we're rewriting it like for this one, right?
Cool. So in the trace, that then comes up as one task. So if you go back in the trace view, you'll see this. It kind of looks like it. If anyone ever used like Microsoft Project back in the day, I'm sure people still use it actually. It looks like a waterfall diagram, this trace. So what it's showing you really is like the time to complete the whole thing, and inside that, what intermediate steps are happening. And what some of the components you'll see is OpenAI.chat. So that's like a chat completions call. You'll see lots of these local hosts. That's actually to do with the authentication. It's kind of how internally in the SDK it gets the authentication tokens. You'll see the embeddings calls so that we need to convert the user's question into a vector and then give it to AI search. And then any kind of Azure SDK for Python or for other languages, any calls within the SDK are supported in OpenTelemetry as well. So kind of the technology that's enabling all of this is a couple of things. One of those is OpenTelemetry spans and traces. This is an open spec and open standard, and all the Azure SDKs use this. We've also done some custom sort of configuration and stuff like that inside the repo so that this works out of the box. So here we're still looking at it in application insights, which is a place that you can publish OpenTelemetry data to and see it in this dashboard in Azure. By default, if you deploy the repository, you will get an App Insights workspace, it's called, and then you'll see all these spans. And then if you've got streaming enabled, you'll see a very long sort of list of all the streaming requests and responses backwards and forwards. Something else that's interesting, if you click on the OpenAI.chat request, and then scroll down, you can see all these custom properties. So this is quite new, this piece. So what we see here is it's not like a new open spec for how LLM should be tracked and traced in the backend. So this spec works with OpenTelemetry for OpenAI. It works for some other LLMs. Also, if you're using OpenTelemetry and publishing it somewhere else, you'll see all that same information and the same attributes. So some of the important stuff we want to pull out here is whether or not we were using streaming. That's what it's used for. What parameters we ask for, so max tokens, temperature, and also you'll get the top argument, top P as well, and then some of the response information back, including the number of tokens that it used. So usage.total tokens comes back, and then completion tokens also as well. So we see like 281 because there's 260 in the prompt and 21 in the completion. So we get that information live. So we can kind of see which requests are using tokens. Because when we go into the load testing stage, with load testing with these apps, you're kind of trying to tread a really fine line between pushing the app to its limit without hitting capacity or hitting the tokens per minute cap out.
Yeah, and what is the difference between, why do some of them start with LLM and some start with Gen AI? Do you know?
That was kind of
a standard.
Because not everything was in the standard. And when we kind of started on this, there wasn't a standard. So the OpenTelemetry team at Microsoft have been developing a standard with some other partners who are involved in OpenTelemetry specs. For now, we're trying to get as much information as possible. It's better to have too much information than too little in these spans. But eventually we'll kind of consolidate that. So LLM was I think LLM is the standard one, and Gen AI is the full one that we've added.
Okay, so it's got a bit more. And we do have some good questions in the chat already. Kind of like two related. One was like, what key traceability metrics do you consider essential for ensuring high quality LLM responses in a RAG system?
I guess if the whole point of these types of traces is that when something has gone wrong and you get a complaint from a user, you can turn back the clock and understand what happened in order for that to occur. And you always do that based on the assumption that the user will provide you with little to no information at all. So, you know, it's one thing to say, oh, maybe if the user gives us like a full log, then we can look at the logs, but they never really do that. They say, oh, I was using it last Friday and it was giving me really weird responses. Why was that? That's the kind of user feedback that we typically get as developers. So the whole point of these traces is that you want to capture this information. You want to correlate it. So we've got these like correlation IDs, but you want to associate, okay, like when was it? So let's say last Friday, which user was it? And then did they get anything on the screen? If they got an error, that's easier because at least you've got something to go on. And if you can print the correlation ID, then you can basically capture that and see that whole span from the front end through to the back end. And we've got all the logs and all the information in there. So that's kind of the ideal what you're trying to do here. I'd say that most of the time in LLMs, a lot of the concerns about quality are more to do with prompt and the interactions backwards and forwards, or the relevance of the search question. But here, really, we're just trying to capture as much information as possible in this kind of span chart.
Yeah, and we talked about quality in the Monday session as well, because that's when I was talking about evaluation, and I also see some other questions like about quality and evaluation. So we're not talking so much about evaluation day, but in theory, you could do what's called like online evaluation. So you could sample a subset of the queries that come in and run your evaluation metrics on it, as long as those evaluation metrics don't require ground truth. So you can run and say like, okay, does this seem grounded? Does this seem relevant? So the usual approach is that you do some sampling, or you do like a certain number per day, and just make sure that your groundedness, relevance, those sort of metrics are staying fairly consistent. That's what I would say for quality. Related to that, Paolo was asking, what would be strange behaviors, like strange metrics other than errors that may indicate a problem, like a long time to respond? Like what kind of alerts could you be setting up here?
Yeah, so in this view, if you go back to the performance page, I'll show you a couple of things we can do.
Okay, let me make this. Okay, yes.
Okay, so on the, okay, so this is chat stream. Just trying to think. Okay, there's another app.
Oh, should I go to your app?
There's a resource group, RG and demo,
Yeah.
RAG demo.
This one?
Yeah, there's two, so we'll compare the two. The top one is GPT-3.5 Turbo. That's the demo set up with that. If you go to the App Insights for this one,
yes.
Okay. Not the Log Analytics, App Insights. Yeah, okay, that's it. Cool. Okay, so if you scroll down, and then we've got the post, not the stream chat, but the normal chat.
Mm-hmm.
You'll see there's 130 requests. On the right-hand side, we've got a logarithmic distribution of the response times for that particular endpoint. So this is our chat completions endpoint for the application that does the whole step and stage. So what we can do in App Insights is we can select like a window. So on that graph, you can select everything beyond, say, 10 seconds by just using the mouse and sort of dragging it across. So if you start, that's like 10,
Yeah.
and then you like click and drag over it.
Nice.
That'll basically show you everything that took longer than 10 seconds. And then it will tell you what is common. So it says common properties underneath that. It tells you what's common about those particular types of requests. And we can expand that, and then we can go to details. So it's saying, okay, most of them were from Washington, Virginia, and that's because that's where I was running my load test from. I'm not in Washington. Is there a Washington, Virginia? No, there isn't. I don't know what that means. Maybe there is.
It probably means Washington, D.C., right? Because Washington, D.C. is somewhat a state, somewhat not. That's right next to Virginia. That's my guess.
Okay, maybe that's how they've done it. Okay, yeah. So then you can scroll down and you can see, okay, in the list, you can see the specific requests. So the first one it's showing me is duration 28.7 seconds, response code 500. So if we click on that one, it's saying that's suggested. So based on what it thinks you're looking for, which is the really slow ones, we can click on that and we can see what happened. In the top, do we get the 500 error, and then there's a stack trace. So we can see kind of like in our span now and in information, like at what point did it break? And I think we've got an initial chat and maybe like an initial embeddings call. And then at some point, we've hit a rate limit error. I think it's actually on the second chat request. It's hit the rate limit error. So if you click on like that error, and then on the right-hand side, you've got the call stack. You can see, there it is, like where the error was raised and what the exception was. And that's a pretty classic issue with these APIs, is that if you, especially when you're load testing them, if you send them too many tokens and your quota is not high enough, or there's basically two thresholds. There's one which is tokens per minute, and there's another one which is requests per minute. And if either of those are exceeded, you'll get a 429 error from the API. So yeah, and you'll see the message details on the right. Says this exception, rate limit is exceeded, try again in 1 second. And because we were load testing it, we'll just keep hitting that endpoint. And we'll get lots more of those. So that's one reason why it was slow, is because there was a retry loop. So it's probably tried a few times, and it's probably paused in between each time. So yeah, that's kind of how we get that information.
Right. So yeah, because the OpenAI Python SDK, it actually defaults to retrying twice, doesn't it? I think it's configurable, but I think it defaults to 2 retries.
Yeah. So then if you go back to the sort of breadcrumb trail at the top and click on the app again, then if you go to application map on the left-hand side under investigate, then with OpenTelemetry, the idea is that you've got the same standard that's used from across all the components in your application architecture. So, we're running the Python backend in a container. There is a front end as well. We don't have OpenTelemetry, I don't think, in the front end, but we can add it in there. If you had multiple services or multiple components running on different environments, could even be different languages, and they're all using OpenTelemetry. As long as you're setting the same span ID on the first request, you can see that trace from back to front. And what we're seeing here is basically what is involved in our application, like what does it look like? And you'll see the center, which is the app, and then it shows the relationships to the other services or components which depend on it. And in this case, we've got OpenAI as the main one. And in this chart, we can see like I think it's the median, or maybe it's the 90th percentile, like the milliseconds that it normally takes to get a response back from that service or that component. So if you click on that, it says 84 calls, and that is for the last hour. So with App Insights, it will either default to the last hour or the last 24 hours, depending on which view you're in. But you can quickly change that if you need to. And here we'll see like the average duration for both the chat completions and the embeddings. And we can expand that if we want to, like the last 24 hours. So this is a GPT-3.5 Turbo deployment. And what we wanted to do with this one was to basically create a load test and then also create another instance, which is GPT-4o Mini, and then run them and then compare them. So I think if we...
Do you want to talk about load testing? Now, well, there is something actually that I wanted to know as well, because you were talking about like correlation IDs, right?
Yeah.
And I know that Azure a lot of times will give you a correlation ID when you run into like an Azure error, like in the portal. But how, as an application developer, how do we pass down a correlation ID? Is that something we should be like, is that something we should be adding to the application code? Like, is that something we can get from App Insights somehow?
Yeah, so in this case, it's done because the with OpenTelemetry works on plugins or extensions, and you start off with OpenTelemetry for Python, and then you install additional packages for different backends or different services. So we've got the HTTP client instrumentator that essentially it patches any calls made using the AIO HTTP client. The HTTPX one, which is used by the OpenAI SDK. There's one specifically built OpenAI now as well. And then we've also got a hook. So the last one, the app.asgi app, is a hook so that it basically listens to requests coming in through Quart. So with OpenTelemetry, what you need to do is to look at what packages you have and then to check that they are instrumented. And then where the request starts is where the span starts, and that's what should be assigning a span ID. We sometimes refer to that as a correlation ID because more or less the same thing. But at some point you need to create that unique identifier, and that needs to propagate through all of the span. The way this app has been set up, if there isn't one, it will create one. And that normally happens when it hits the API route for the first time, which is in Quart or Flask, and it doesn't have a span ID, so it makes one. And then that is what starts and is captured in OpenTelemetry. Okay,
so we would want to, like just looking at like the code, right? So this is what I just showed you. And that happens just once, like when we're setting up the app, but the span IDs would be, specific to, like the user comes in and this happens. And then if there's an error, what we really want to do is actually get that span ID that we can then send down to the UI and say, there's been an error. You can use this correlation ID.
Yes. Yeah. So if you do display an error to the user, you can do it that way. Another slightly more advanced option as well is on the front end. If you do any tracing on the front end, you can assign the correlation ID, the span ID on the JavaScript app, and then you send that in the backend request. So as an extra header, you can say this is the correlation ID that we have already created on the front end. And the difference you then see in App Insights is you'd see the call from the front end to the back end and back again. So if after getting the response, then it crashed. You know, in the React, one of the React components, for example, crashed, and you got the exception. You could see like what request caused that, what response back from the API in the back end was sent back, and then you see like at the last hurdle, the JavaScript exception, and then like where that was in React. So you can do like a full end-to-end trace essentially.
Yeah, that's really nice. I think we do want to add the JavaScript App Insights SDK to the front end, because there's a lot of people who want to do user tracking. And the way to do that is to use the JavaScript SDK and instrument that in the front end. So maybe that's what we'll end up doing.
Yeah,
that's really cool.
Yeah, in the chat, someone's pointing out how useful this is for debugging. It's, yeah, like I say, for like postmortems and stuff like that, where you've had incidents, especially ones that are really hard to pin down what caused them. This is so helpful to kind of wind back the clock and just see what scenario, what situation caused this.
That's awesome. Okay, so I think now we can talk about load testing.
Cool. So the technology that we kind of picked for this this application, and the one that I'd recommend generally for Python apps, is Locust. This is a free open source library. You can download it and run it locally on your machine. So you can run Locust. We've already included the Locust script for this application in the repository. So you'll notice in the root of the repo, there's a file called locust file. It's a Python script. And I'm just going to bring that up.
Yeah, and let me just pull, because you just updated it. Oh, I'm on a, okay. All right, well, it's okay. You get the generator.
Yeah, so the way locust files work is they're Python files. So you define a user, which represents this thing that you want to simulate. And then each user has as a class, and then you put methods in that class that represent the tasks you want that user to perform. And this is kind of where App Insights, the two things work together. Because what you can do in App Insights when you've got the front-end telemetry is actually, if you just switch back to the App Insights tab, Pamela, if you go down to usage, and then you go to users, then you'll see, actually, you probably don't get much information because we don't have the front end tracing. Normally where you go is to users and then to user flows. So user flows is on the same section. If you go on the left hand side, user flows. So if you've got front end telemetry configured, what you'd say is from the starting point, which is like people going on the website to just the initial page, like where do they go after that? And this is all back-end calls, so it's probably not going to make a lot of sense. But what you should see is like a Sankey diagram where you've got like a flow of users, like, oh, 50% of the users after starting here will type in a question. 20% of them will log off. So you can kind of see like what users typically do, and then what steps, and then what order. And when you're designing a load test, that's what you're trying to do, is you're trying to simulate the load of real users in order to try and understand how that impacts performance. And hopefully doing that ahead of time. So before launching the application or before making changes and things like that, you want to programmatically simulate user load. And this is what we do in a locust file. In the locust class, so we inherit from HTTP user, and as part of that, you get a client. So your class basically has a thing called client. It's an attribute. And you can do get and post requests on that client. So we're essentially making HTTP calls from the client, and we can send JSON backwards and forwards. We can also get HTML, and we can parse the HTML if we want to as well. So this is really kind of simulating a low level the HTTP requests that the user would send to the backend. And the reason we do that is because we structure that as a task. And what we've done in our load test, we changed it just slightly yesterday. but it's really the same kind of steps. Is first you go to the home page, then you ask a question, then based on the follow-up questions that the RAG suggests, we will ask a second question. Excuse me. So we're basically simulating that in a script. And the cool thing about Locust is you can run it locally, and then you can just give it a endpoint. You can say how many of these users you want to create. So I think if you just type Locust actually, or detect the file in the same folder.
True. Yeah. All right, let me do here. Let's see. Okay, so number of users. You were doing like 2, right?
Yeah.
Let's see. Should I do it against yours? Because you've got one deployed.
Yeah, we can do that.
All right. So what we do is we're gonna find the endpoint, or I can do it against the one I have deployed, but then it's gonna 429. Okay, here we go. Let's see how quickly we 429. Okay, so we'll just do one user then. Let's do 2. Let's just see. Because remember, so we're gonna get rate limit errors if we're, if we have really low TPMs. Like this one, I think I've only got like 30,000 tokens per minute, and you can imagine like a question takes about 1,000 tokens. So we'll see how quickly we get some rate limit errors. But here we go. So 2 users, 1 user per second. So there's a gradual ramp up. That's the endpoint. All right. Looks good.
Yeah, that should be enough.
Dun, dun, dun.
Okay, so what you'll see is the GET requests and the POST requests eventually. And the way the Locust script is structured is to simulate basically what the user would do, and that is to load the page, wait a few seconds so they can actually realize where they are and type a question, submit the question, look at the answer, and then wait a bit more and then send another question. So with load testing, it's really important to put pauses in between the actions and to randomize the pauses, because that simulates what real people do. What you'll get in pretty much every load test for every application is you'll get a big spike at the beginning in the response times. They'll be really slow whilst it kind of warms up. And then once that's happened, it will drop down and you get a stable rate. So the response time should be pretty stable after that. If you see it jump up, that especially with these applications, that typically means you've hit some sort of rate limit, or it's doing a retry in the back end. So we can see now we've got, like in terms of our 95th percentile, it's just above 2 seconds, which is fine. Like that's fairly acceptable, especially if you've got streaming on and the time to first token is like half a second maybe. I think users are okay with it taking a couple of seconds to write back the response.
Yeah, and this is doing the chat endpoint, because a lot of times when we do the load test, we do this chat endpoint instead of the streaming endpoint, because it's just easier to monitor, because you're not getting so confused by the effect of streaming.
Yeah,
but something to keep in mind too.
Yeah, definitely. So that is sort of how you can run Locust locally. There are some limitations with this. You're limited by the hardware that you have. You're also limited by the latency between you and the thing that you're testing. And then also, if you want to automate this, so I've got some examples of where you can include like running the Locust test as part of your deployment. So if you've made a major change, you could run a performance test for a couple of minutes and then save the results. So you can kind of see historically how it impacts performance. So if you jump back to the Azure portal, then in my RG and RAG demo resource group, I've added another service component, which is called Azure Load Testing. And we have in preview, so you have to sign up to the preview first, is the ability to run Locust tests in Azure Load Testing. So Azure Load Testing is load testing as a service, and you can upload a Locust file or a JMeter file, and you can tell it to run on a single instance or any number of instances. You can scale this up to a lot of nodes, probably way more than you're ever going to have the capacity to on the LLM side. But it is really helpful when you want to do things like if you've got something that's heavily cached and you want to see like how many users you can get through it. That is really helpful. So what I've done is I've run that load test and I've run it for 5 minutes. And then I can look on the stats on a few different things. The response time in particular is really interesting to me. So I can see this is the 90th percentile. So you see this is aggregation P90. So the 90th percentile means what is the time that 90% of people would get. If you order everybody in terms of like fastest to slowest, then include the sort of outliers, the sort of 10% slowest outliers. That's really helpful because when we saw that kind of ramp up at the beginning, when the app warms up, we're basically excluding those numbers in the average stats because of the way averages work. It would just kind of skew all of the results. So we say, okay, if we just ignore those slow 10% of users, then what does the response time look like? And you can pick that if you wanted to see the 95th percentile, the 99th. You can just change that in the graph.
Can I do? Oh, I want to do that one. Oh, we do have a question. Can you with Azure load testing? Can you simulate a location of origin?
When you deploy the Azure load testing resource, it needs to go into a location. So if you wanted to simulate users in West Europe, for example, and the application was in East US, then you'd put the Azure load testing resource in West Europe.
Mm.
You can't tell one instance of Azure load testing to route traffic via a different data center, if that's the question. You'd have to put the load
you need to
testing
actually
resource
put it
in that
place.
location.
So you wouldn't just be simulating; you would just literally be a user from that location.
Yeah, it would be a real simulation. So there's a question, curious to know about the additional costing involved running a load performance test as part of deployment. Is it worth doing that as part of a deployment or that on an ad hoc basis? So the cost implications are, I guess probably the most significant one is going to be your LLM calls. So that's what you'd need to factor in. And that's why I say I'd run the test with a handful of users, and I'd run an ad hoc test that is really trying to understand what the ceiling is. So if you want to understand how many users can we have on the application at once until we start to hit rate limit issues, like that would be an ad hoc test. I wouldn't do that in CI/CD because just the cost involved. Doing an automated test in CI/CD, I would do a short one, so something that runs for, let's say, like a minute, and I'd do like a predictable number of users and try and cap that as well. If you can do that in a quiet time of day as well, that's ideal, because if you're running it at peak time for the users in that region, then you're also going to skew the results. So yeah, it is helpful to know. It's important to understand like what you're trying to understand with the performance of the application, because the LLM piece at the moment is often like the slowest part. You know, the LLMs, there are definitely, you know, it definitely takes a few seconds to respond, whereas with most pieces of modern applications, you know, it's tens of milliseconds, if not like half a second, maybe at the most. Database calls, any kind of page rendering, stuff like that is normally like 100 milliseconds. So you kind of introduce this thing which takes a couple of seconds. One thing I think is important with this, if you go back to all test runs, there's two tests, the top two. If you click on those and then click compare. So what I've done here is I've deployed the app twice, and then the second one, which is in purple, I've deployed it with GPT-4o Mini in the global standard SKU. And so, sorry if you don't, there's a lot of terminology in there, but they basically introduced a different model, and I've run the same test at the same time on two different instances to understand how does that impact performance. because I've changed a lot of things all at once. I changed from GPT-3.5 Turbo to GPT-4o Mini for both the query prep and the rewrite, the final generation step. I've also switched the embedding models from Ada 002 to the new text embedding small model with 256 dimensions. So I've like changed a lot of stuff, but the code is the same. It's just all the back end pieces are different. And then run a load test to understand what does the performance look like for both of those for 2 users. So I wouldn't take this as gospel, but it looks like one of them is slower than the other. So
okay, but I know why. Let me tell you, because I know why. Let me show you, because we actually this came up yesterday during evaluation, because I ran a similar test with evaluations. Oh, but I was messing with it here. But basically what we found, I evaluated GPT-4o Mini versus GPT-3.5 Turbo, right? And that's what you also evaluated. And the latency was way higher for GPT-4o Mini, but so was the length of the answer. That was what it correlated to exactly, was that what happened is that GPT-4o Mini is generally giving longer answers. It was like an average of 600 characters for 3.5 Turbo versus 900 characters for 4o Mini. And then I actually looked at a bunch of answers and compared them. And even though you would think like generally we like to have short answers, but GPT-4o Mini, it had longer answers, but it also tended to use more bullet points and more bolding. So even though they were longer answers, I felt like they were like more readable because of like the use of formatting and lists, and people tend to parse lists. So because we've been debating whether to like move over to GPT-4o Mini and like whether that's going to affect people. It definitely will affect people, because if you don't change the prompt at all, you're going to spend more money on tokens, and it's going to take longer to get the final answer. But I think the answers might be better. Like they might be easier to understand. So this is what's fascinating about changing models. Like so much can change.
Yeah, definitely. So we can, if you go back to the App Insights pieces.
Okay, I'm open here.
So we've got, this was our GPT-3.5 Turbo instance. And then if you go back to the resource groups, there's a second one.
Should we go to your other one, AntRag?
Yeah.
GPT-4o. Yes, this one.
That one, yeah. So this is the other one. And then we can understand like what happened in the other one. So if we look at performance, and we look at all the chat requests, then we can drill into the samples and understand, okay, we've got, and if you look on the graph, actually, if you get back, sorry, there's a bit of delay between the two. If you click on the post chat on the left-hand side, the operation, you'll see there's like 2 clusters of response times. And this is where it's kind of interesting. So we've got the ones over on the right-hand side, which are probably the ones where it got throttled or something went wrong. And then you've got the kind of main cluster, and it's saying that the average is like 3 seconds. So in the 50th, it's saying that that's about 3 seconds. So if we select some of those, so we sort of select that time range, then we can click on the drill into the samples, and then just pick any of those. So they're all roughly the same, which is about 2.5 to 3 seconds. Then we can look at what is taking a long time, and it looks like the second chat request is the thing taking the longest. So the first one is 800 milliseconds. The second one is 1.4. And what we can do now is we could go and put side by side, our 3.5 Turbo application flow and our new GPT-4o Mini, and we can look to compare, is our embedding call the same kind of window? Like this is 57 milliseconds now. Like, is that faster or slower than the old one? And this is kind of what we get with that full trace, is the ability to drill into the information and look at it in more specific detail. And the other point you were making about it does take longer, but it's giving you longer, richer answers, which is what we'd hope for. Then if we select sort of median, so like the 50th percentile, and just pick one of those samples.
Here we go.
Cool. So we've got the initial chat request, which is 318 milliseconds, the embeddings call, which is 46, and then the second API, the second chat request, which is 1.1. So actually, like the timeline looks a little bit different. And I think what we've got in Mini is maybe a bit more latency on the initial one, actually a little bit more on the second as well. And the embeddings call is not much different. So I think initially we kind of heard that the new embeddings model was faster, but we're still talking like 46 to 57 milliseconds, which is nothing. And most of the time here is spent doing either two chat completions. So what we can do is we can look at those two side by side, click on them, see how many tokens it was generating, and what the settings were and the parameters were as well. So like we can see like the number of tokens, and we can see the responses as well, for essentially the same question, because the load test is picking one of three questions randomly and asking them over and over again. And we can also see like the specific model and the model version as well.
Yeah, and you can see it's both a lot more tokens, but also just generally taking more time. Yeah. It's super interesting. And so this is also something you can find out with evaluations as well, if you're measuring latency in your evaluations, which is what we usually like to do. Cool.
Yeah,
okay. Let's see. Yeah.
So if you get a user come back to you and say, I was using the app and it took half a minute to respond, you know where to go. You can come in the dashboard, you can drag the slider to the right-hand side, find the slowest response, click on it and drill down into exactly what happened. And you can see like what they asked and stuff like that. If you've got any privacy concerns, or you've got any extra like legislation or rules or anything you need to do with, like, especially if the actual prompt from the user, if you don't want to trace that, then you can customize that as well.
Yeah, so we have a question from Paulo. How important is it for the end user, the difference of the response in milliseconds? Streaming makes it seems like an almost instant response. It's a good question. I think we need some user research here. I don't know if I've seen any. I mean, I think a general best practice is to make sure there is a streaming option, because that definitely helps with the latency to be able to start seeing it. But I think there's also kind of patience of the user. I've certainly heard anecdotally that people will be like, the responses from this model are too slow, right? And then they like switch to another model.
Yeah, it also depends on like what you're making. If it's a user-facing app and you've got no spinning icon, or you're not using streaming, or you've given no feedback to the user that it's thinking about it, I think if you, because don't forget the time to first token won't be has to do the first chat request, the embeddings call, and the search, and then we only start streaming back the response after that. So on the time scale, we're still looking at about 800 milliseconds, about a second. There are plenty of users I know that after a second would click the button again.
Yeah, and that's why some people suggest that like you should have more intermediary, like kind of loading things, like, because you could say like after the search call comes in, you could actually stream down an event to the UI that said retrieved 3 search results, right? Like just to make the user feel like they've progressed more in the process, and that can feel like more okay than just watching that loading indicator for a whole second.
Yeah, definitely.
Robbie also asked, should we be tracing the backend vector database as well? So in this case, this is using Azure AI Search. And wait, how does this one have 0? Wait, what happened here? Oh, okay. That's just how this shows up in the UI. The actual thing is the search post, and you can see it takes 159 milliseconds there, 286 milliseconds there. Was that with, because you use small. How large are you use small? What dimensions did you use for your text embedding small?
256.
So that's actually a difference, because the default is I'm blanking now. Is it 1584? The default is much larger, right? The ones we're using with text embedding 0, ADA02. So it looks like we're seeing actually that our calls to Azure AI Search. Now, this is anecdotal. What we need to do is look at all of these calls across all of them and see if they all got much faster with text embedding small 256. But it would make sense they would. Like if your vectors only have 256 dimensions, it's probably going to be a more efficient vector search. So that's definitely something to be looking at as well. Anthony decided to do two things at once. So that we have both these factors to look at. But like, could we look at, like, can we just group all of the search post calls and to see like what's, between these two repos, could we look at all the search post calls and see just the duration of those to see what like kind of the median is across them both?
Yeah, you'd have to. I can't remember how you do it in the portal now. I think you have to go via another part and then create a log specifically.
Okay.
I can't remember how you do it now though. So, and what you're seeing is, there is no like rich telemetry for Azure AI Search calls. It's really just capturing the fact that there was a HTTP request. Like, it doesn't give you any more information than that. You can kind of see in the request like what it was doing, but you don't get much more granular than that. If you want to capture information, like any of the stuff that comes back, you'd have to write custom code to do that.
Yeah, but we should be able to do like some sort of filter to see the median duration so that we can confirm that like moving to this lower dimension model was speeding up our calls. And like when I've also done RAG on Postgres, it has been super helpful to look at this view to see how long my Postgres queries were taking too. So that's definitely a consideration.
Yeah, I would have thought that probably the biggest difference to the performance that you could get would be moving to a different SKU or a different deployment model. That would reduce the time to first token down the furthest. And in Azure terms, that's called PTU. So that's sort of allocated provisioned units of compute specifically for your app.
Yep. All right. So we are at time. We haven't made it to, well, we're over time. We haven't made it to all the questions. Paulo did ask what Azure services are needed to fully monitor the app. Like, what is the, what's the MVP? What do we use for a small app? What do we use for full? Like, what's the range there?
Yeah, App Insights and a log analytics workspace are the two things that you need. So we need to, the dashboard is kind of part of the log analytics workspace, but the two things work together. So you need the log analytics workspace and you need application insights. In the grand scheme of things, both of those services are pretty low cost. It depends on the volume of data that you're capturing. Some customers only keep like full trace data for a certain percentage of requests. Like if they're huge, like apps with millions of users, they only capture like full trace spans for like 1% of requests. And that's something you can do in OpenTelemetry. There are like the span exporters or some of the extensions, you can say only do this 1 in 100 times. And that's kind of one way to keep the cost low. And people also do that because it reduces the overhead on the back end to find all this information and capture it. But yeah, those are the two things you need.
Awesome. And then if you wanted to use Azure load testing, that is additional service and additional cost.
Yeah, that's right. And the Locust integration is in preview. So you'll have to, once you provision Azure load testing, there's a button to say you want to join the preview and you just give it your subscription ID and then somebody should approve that pretty quickly.
All right. Is there anything else you wanted to mention?
Yeah, I think if you're using VS Code and you're working on Locust files, watch this space. I think we've got some more integration with Azure load testing from VS Code coming soon. So you can run the load test locally using Locust, and you can also, it can automate the creation of the load tests and uploading it into Azure load testing as well. So yeah, watch that space. There should be a preview available pretty soon, I think.
All right, so we should have an extension coming soon. Better integration with VS Code, very cool. Okay, so I have like a couple slides on error handling, but just wanted to point out that Azure OpenAI does have, special errors. We did see 429 in, we saw that rate limit error. There's also special errors for content safety violations that's risen by the Azure OpenAI content safety filter. And there's also a special error for context length exceeded. And we, in the app, we actually present special messages to the user based off those errors, just because they are so, they're so specific. But that's something you might consider special kind of monitoring for, like maybe on your dashboard, like you want to be monitoring how many content safety violations you're getting, like making sure not too many. And then also, like generally you don't want to be going over context window length. So you have to, anytime you're monitoring your app, you have to decide like, what's worth having an alert for, what's worth having pager for. Ideally, you don't have to have pager for almost anything, and everything's automated. It's just whatever. You have to consider all the kinds of errors that can happen and what sort of monitoring you want to set up for them. And we do have handling in the app code itself, in the Python code, for some of these errors, like the content filter and the content length exceeded. We could even add one for 429. Ideally, if you set up your OpenAI with the right capacity, users don't have to see that. But it could happen. So that's something to consider as well, is that you can be logging these errors and also handling them specifically. All right, so that brings us to the end of today's session. Thank you so much, Anthony, for figuring out how to set up your phone so that we could get all your expertise, because that was much better than me trying to be pretend Anthony. And yeah, so that was really, really helpful. And thank you everyone for all the great questions so that we could learn more. And we will be seeing Anthony again next week for our final session, extending RAG with function calling. Maybe Anthony will have a new computer by then.
Have a new laptop by then.
Have a new laptop by then. Well, stay tuned for the exciting saga of Anthony's laptop. So do join us for our final session of this series next week. And I also have office hours on Thursdays. And I know some of you are already planning to come. So we can explore whatever you want to explore in those office hours. They're usually a lot of fun. And that's just in our Discord, and we're putting the link in the chat. So yeah, if you have any additional questions you didn't get to, or things you want me to try out, come to those office hours and we will try them out. And Yash wants to know why I have war paint on today. Well, it matches my tie-dye. I don't know. Last week, my excuse was the Super Bowl. Or Super Bowl? That's what's called. Yeah, the Super Bowl. And this week I don't have an excuse, except I do say the Super Bowl halftime show was really good. I didn't see the rest of the thing, but I have been watching that over and over. So that's my excuse. All right. Thank you, everyone. And thank you again, Anthony and Anna, also for hosting us. And we'll see you all next time. Bye.
Bye.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.